Electricity, this is how we know it. It's an everyday thing. But how did this piece work? We'll tell you.
Electronic charges can move in one direction when it goes from a negative pole to a positive pole. That's called a circuit. When electrons float, we call it electric current. The amperage gives amount at the floating electrons in a certain time. In a circuit, there is excess of electrons and the plus pole electrons are missing.
The bigger the cross-sectional area of the cable is, the more electrons float. Same and changing currents are different. If you take a current source in a battery, the electrons move in one direction from the minus to the plus pole. If a current always floats in the same direction, we call it a direct current. There are also power sources, which poles always change. Out of plus will be minus, and also the other way around. Since electrons always go to the plus pole at every pole change, they change their direction. A current in which the poles always change, we call it an alternating current. The alternating current is not just the voltage that must be shown, but also how often the direction in 1 second changes. This is the frequency of alternating with the unit hertz. So we did a small experiment. This experiment contained a 6-volt light bulb, a 4.5 volt battery, and a 1.5 volt battery. So the light bulb lit up like this with the 4.5, and like this with the 1.5. So that meant that since the light bulb required 6 volts, the 4.5 volt battery gave it more volts, so it lit up brighter. And since the 1.5 isn't as much, it didn't lit up as bright, so it was more darker. So that's how the experiment worked. Thanks for watching, and we hope you enjoyed.